A very good evening, guys. I just start recorded this lecture. You can see my slide, right?
Yes,
Okay.
sir. Yes.
All right, good. Okay, previous class, we stopped at what analytical chemists or analysts can do. Okay, what can you do by knowing this knowledge, by learning this knowledge, right? There are a lot of things that you can do with analytical chemistry knowledge. Okay, developing methods, all right? Learning about the instruments, apply the knowledge for the necessary modification of any methods, right? Interpret data, evaluate, and also evaluate and interpret data, and as well as quantitative analysis. All right. Now, this is the analogy. We have two types of analysis. The first one is quantitative analysis. Okay, and the second one is qualitative analysis. As I said in previous class, right? Qualitative, we go to qualitative first. Qualitative is about what analyte present in the sample. For example, if we can say that does volatile organic compounds exist in the air sample? Is it exist? And what type of analyte of VOCs? Okay, volatile organic compounds, the short form, the acronym is VOCs, VOCs. Right. What type of VOCs exist in the polluted air? Okay, for example, benzene, toluene, and also xylene. Okay, that is qualitative. What type of the pollutants exist in the sample? But if you say quantitative, we are talking about how much of that analyte, that particular analyte, present in the sample. For example, previously I said VOCs like benzene, toluene, or xylene exist in the polluted air. And now how much of it? So that is quantitative analysis. For example, 5 part per million, 5 ppm, right, of the benzene exists in the air sample. So that is quantitative, right? Rather than just we know what is a type of analyte present or exists in the sample, that is only qualitative. Okay, right. Right, and these two technique of analysis acceptable in worldwide. Okay, more valid and accurate for reporting. Which one? Okay, not both. Qualitative only for just to know what type of analyte, but the quantitative is acceptable worldwide for the reporting. All right. All right. Forget about the class activity first, because we have done that. Okay. Okay. This one we can do. Okay. Just imagine that you are a chemical engineer working for a coal-fired power plant in Kappa Energy Venture. That is a company name. All right. Twice a month, the company KEV bought a medium quality coal from Indonesia. Today, when the shipment arrived, you suspected the coal is different as the previous batch. Okay, from the photo given, that is the coal. That is a power plant energy company. Okay, what should you analyze? Okay, in chemical analysis perspective to give your answer for the suspicion. The suspicion is about the quality of the coal. Okay, the coal is different from the previous batch. Okay, and what is a sample? The second one, what is a sample? The third one, what is the expected analytes? Okay, and then the fourth one, what is the matrix? And the fifth one, should these be quantitative or qualitative analysis? Okay, anyone can the first one first. Number one, what should you analyze? Okay, anyone can volunteer to me? Okay, from the coal sample that you suspect that is the different quality. You as a chemical engineer at that energy company, your company bought a coal from Indonesia, and you suspect that the quality of the coal is different from the previous batch. Okay, the first one, what should you do? What should you analyze? Okay, can you give your rough idea? We just we are in process of learning right now, so give your rough idea. For number one question, what should you analyze? Come on, just give your idea first. I prefer if you can open the mic and Shomya, you give the answer to me privately. I prefer that you share with all. Okay.
Probably the components in the coal, doctor.
Component of the coal.
Yeah.
Okay. A good example. Component of the coal that we can measure, that can represent the quality of the coal. Okay. For example, do you have any more specific ideas from you? The quality based on what?
The moisture of the coal, doctor.
Moisture. Who said that?
Loga.
Loga. Good. Okay. Moisture. Good. Okay. A good idea from Shomya and also specific idea from Loga, which is the moisture. Of course, we don't want a high content of moisture in the coal because it's hard for us to burn the coal. Right. So the quality based on moisture. Good one. Okay. And what is the sample? Anyone else? What is the sample?
Coal,
Come on.
Is it the
Who's
coal?
that? Who's that?
Ain.
Ain, yes. Your answer?
The coal?
The coal. Which coal? The previous one or the latest one that have been suspected with low quality?
The latest one.
The latest one. Good. Okay, good, Ain. Okay. And what is the expected analytes? You are talking about moisture. So what is the expected analytes?
H2O.
Water. Yes, correct. Water. Okay. And what is the matrix?
Dust.
Yes.
Dust.
What? I can't hear you.
Dust, doctor. Dust.
Dust. Okay, dust. Kan? Dust or ash. Right. Good, good. And another matrix? Anyone? Like I said, other than analyte, other metrics. Okay, what are the metrics inside the coal? If you can, give your rough idea. Come on. We have 62 participants right now. Wow, this is full. It's full house, guys. Okay. What is the another metrics rather than the dust or ash inside the coal? Come on. Anyone?
Doctor?
Yes?
Carbon.
Carbon. Okay, good one. Carbon because you want H2O, water, but we don't want carbon. Yes, okay, that's good. Matrix. Anything else that we can consider as matrix?
Sulfur.
Yes?
Sulfur.
Sulfur, yes. All right. So any other elements rather than H2O, okay? So other metrics that can be can disturb or cannot disturb our process of analysis for moisture. Okay, number 5. Should this be quantitative or qualitative analysis? We want to compare the latest batch with the previous batch because we suspect that the latest batch have a low quality, okay, different quality. So should it be quantitative or qualitative? Remember, this is
Qualitative, doctor.
qualitative. Qualitative. Why? Can you give your reason?
Probably it's because we are analyzing the moisture of the new coal.
Okay, we are analyzing. Then how to compare with the previous batch? If you say that qualitative, that we analyze just okay, there's a moisture inside the the latest batch, the latest batch that arrives at the company, okay. And how to compare with the previous batch?
The amount of
Moisture rate.
moisture in the new batch.
Yes,
Is it the amount of moisture in the new batch? Is it more
So
or
if you
less?
said amount of moisture, who said that?
Logar.
Loga. Okay. If you said amount of moisture, okay, does it represent quantitative or qualitative?
Quantitative.
It is amount. This is quantity, right? So qualitative just yes, exist or not exist. But now you are, an engineer of a really big company that you want to compare the quality. You need to report it after this. So it should be very clear and very precise. So it must be quantitative. Okay, from the report you can come up with there's a 50%, or that's too much. Okay, this is 15% of moisture inside the coal rather than the previous batch, only 7%, that is it, precisely. So that is a better one, quantitative, because you need to report it. Okay, so remember, if you want to compare, okay, with different sample, okay, precisely, okay, because it is really important, because you want to convert the coal into energy, right? So it should be quantitative. All right, like I said in the previous slide, the quantitative accepted internationally, globally, okay, with the standard methods that we can use, okay, so the report will be accepted, globally, as well as analytical report accepted in the court for certain cases. Okay, if we done it properly with the standard methods, with all the the following all the requirements, so the report are really important to be presented at any level, including the court. Okay, so it must be what type of analysis? Again, what type? Number 5. Quantitative. Okay, because we want to do reporting after this. All right, guys, next. Okay, case 2. Okay, a burned body was found outside a suburban house. The police officer treat this as a homicide case. Based on the investigation with the neighbors, they heard 2 people quarrel the night before. Okay, bertengkar, quarrel. Okay, assume you are the group wearing the suits. You are the policeman. You are forensics officer. Okay, CSI Miami, CSI Johor Bahru. Okay. From the photo given, identify, number 1, what should you analyze to know what kills the disease? Number 2, what is a sample? Number 3, what is the expected analyte? Number 4, what is the matrix? And number 5, should this be quantitative or qualitative analysis again? Okay, this is a homicide case. Okay, just assume you are the policeman now. Okay, from your idea, okay, number 1, what should you analyze to know what kills the disease? Please give me idea. You have watched some, series, right, about the CSI. Okay, anyone? Come on. Come on.
Doctor, I think we analyze what chemical that's used to burn the body.
What chemical that used to burn the body? Okay, because it's okay. It was found burned, right? Yes,
Yeah.
that's a really good one. Okay, who's that talking? Who's that answering?
Abdurrahman.
Abdurrahman, thank you so much, brother Abdurrahman. Okay, so what chemical, if there any chemical that causing the causing the disease burn, okay, is there any chemical? So what is the sample? I don't want Abdurrahman to answer it. Anyone else? Other than Loga,
burn body?
Loga, yes, a lot. Yes, who's that?
Is it the burn body?
The burn body. Okay, the part. Do you mean the parts, the body parts? Okay,
Yes.
the skin, the flesh. I mean that.
Yes.
All right. So the body tissues, right? Are the sample. Okay. Now number 3. What is the expected analyte? Abdurrahman said that any chemicals. We analyzing the chemicals that causing fire that used to burn. Okay. The body, maybe. Okay. Or the body really burn with something else. We don't know. So what is the suspected analyte? Come on, give me your keywords, your idea.
The
Okay.
chemical that burn the body?
Yes, the chemical that burn. Or we can call it as the flammable chemical. Okay. Okay, the flammable chemical. To know that is it the keyword is for this forensics in fire. We call as, is it an arson case? Arson. Okay. You can take a note, arson, ARSON. When we said arson, that mean that somebody burn it. Arson. Okay. Somebody burn it. Okay. With any purpose. It's not an accident. Okay. Someone burned it. Okay. We call that as arson case. Okay. So when arson case, there are maybe some chemical that causing fire. We call as a flammable chemical. Flammable chemicals. Cool. The flammable chemicals are our analytes right now. So we take the sample, okay, the body tissue sample. So what is the matrix? Remember, metrics that other than analyte are all the other metrics. Okay. Come on, please. Number 4, easy one. The sample now are body tissues from the disease. Come on, anyone?
The body ash.
The body ash. Okay. Lee Wan Yi. Oh, I just opened the chat. Lee Wan Yi said forensic analysis. Okay. And sample Cedric Henry say Cedric, are you meaning carbon as metric? Right? Carbon, yes. Who answered open the mic previously?
Yeah.
Somya. What is your answer, Somya?
For the expected, what the matrix I told body ash.
Body ash, okay, can also be the matrix or carbon, right? Carbon, right? But carbon, okay, carbon can be also the flammable chemical. Let's say, they are using, the arson case was using the alcohol or any flammable organic chemical. So carbon is one of it. So maybe carbon is not so good answer. More specific, we can say as the body tissues, okay, like the body cell, okay. But we just focus on the flammable chemical. Okay, what else can be the matrix?
Blood?
Blood, okay, and any all others, other things that exist in the sample besides the analyte. So number 5, should this be quantitative or qualitative analysis? Okay, because we are focusing on the idea from Abdul Rahman. We are analyzing for any flammable chemical. Then, right? Is it an arson case? What is the chemical that causing the fire? So is it quantitative or qualitative? At the first glance, at the first first situation, we want to know, is it accidentally burned, or is it arson case? We need that someone put the fire.
Qualitative.
Qualitative, who said that?
Shumya.
Huh?
Shumya.
Soumya again. Soumya very active now after Deepavali. All right. So really good, Soumya, because we want just to know is it arson case or not. So qualitative. When we confirm that there are flammable chemical exist, then we can confirm that it is arson case. Okay. So thank you, Soumya. Right. Good one. All right. This is a step in quantitative analysis. Okay. The first one, we understand and define the problem. Like two example, we know the problem, and then we do literature search. Why we do literature search? Because we want to select a specific, a specific and also a suitable analytical method. Okay, for what? For the sampling process, for the sample preservation and sample preparation process. Okay, so sample preparation, the main thing in sample preparation is to eliminate interference. Okay, as I said, the metrics, we learn about the metrics. Okay, metrics will disturb, some metric disturb the process analysis. So we don't want a lot of disturbance, a lot of, a lot of things that can disturb our analysis. We want to eliminate them. Okay, this is called a sample preparation process. We want to prepare the best condition of the sample. Okay, and what about the sample preservation? Anyone can give me idea what is sample preservation? Before we do sample preparation, we need to do sample preservation. And of course, after we do, before we do sample preservation, we need to do sampling process, taking the sample. After we take the sample, we preserve the sample. So what is the preservation, sample preservation? Okay, sample preservation is we want to keep the sample as as the best as we can, representing the original one that we take from the site. Okay, for example, we take the water sample, we need to preserve. For example, we want to analyze the bacteria inside the water sample, so we need to preserve in order to bacteria to for the bacteria not to not to die, or not to any other bacteria from outside grow in the sample. So we need to preserve the original bacteria. So we need to put some of the chemicals. We need to maintain the low temperature. So that what is called sample preservation. Okay, and sample preparation, as I said, we want to prepare a sample as best as we can before analyze, and then we do analysis process. Okay, after we take the sample, the right method. Okay, taking the sample also consider really specific and right method. Okay, then sample preservation also need a specific and right method. Sample preparation also need a specific and right method for the particular analysis. Okay, so what is analysis? Analysis is to perform measurement of the analyte and compare the result with the standard method. Okay, compare the result with the standard method, meaning that we are using the standard and acceptable method globally, worldwide, so that our result from the analysis can be presented, can be reported, and can be used for all purposes, including in the court. Okay, because this is legit, because we use a standard method that's accepted globally. Right? Understand, guys? Understood until now for this stage?
Understand, Doctor.
Right. This is one of the okay, good. Okay, this is one of the case study. A case study in forensic chemistry, the Bali bombing. Okay, you know the Bali bombing that happened, I think around 2000 something, 2002, yes. Okay, at Bali, the Bali bombing that causing a lot of, a lot of deaths, okay, and then injured people. Okay, so that is one of the forensic case that need to be studied, to be collected all the samples, because the one who did the case, the crime, need to be what we call as need to be judged. Okay, need to be to bring all the suspect to the court and to prove, okay, what happened during the bombing. So it needs really, it involves a lot of analytical chemistry method to take the sample, preserving the sample, analyzing the sample, comparing, and so on. Okay. So it is important to understand and define the problem, learn as much as possible about the overall problem that's being faced. What is the problem to be investigated? Is it qualitative or quantitative analysis that need to be done? When will the result be needed? How many samples need to be analyzed? Who will use the information, the provided evidence, and so on? So this is need to be planned first before the analysis process. Okay. And also how accurate and precise does it have to be? How sensitive the method must be? What is the budget? It's also important. We want to choose which instrument that we need within the budget. How the sample is obtained, the sampling process, also important. If we're wrong, taking the sample, okay, or sampling process, and then all the process will be wrong. Okay, the first process is sampling. Okay, remember this quote. Remember this quote. This is from the industry player. Okay, my friend is Petronas. Okay, in the environmental company. Okay, and so on. The sampling process is really important. The quote is like this. The best practice is for the sampling, rubbish in, rubbish out. That is a simple quote. Meaning that if you sample or if you take the sample wrong, okay, the process of taking the sample is already wrong, and the whole process will be wrong. Rubbish in, rubbish out. You cannot use the data that been analyzed, okay, that you analyze the sample, because the sample itself is wrong, so all the process will be wrong. So it's waste of time, money, and so on. So it's really important to know how to sampling, okay, and of course how to preserve the sample, how to prepare the sample, and the last one is how to analyze the sample. But if you take it wrong for the first process, sampling process, all the process will be wrong. And then does it require any preliminary treatment? What separation must be required to eliminate interference? Okay, this is for the sample preparation. Okay. Okay, this is after the problem is defined. This is will dictate to this, this thing that you need to identify. Okay, and now, okay, I said previously several times that we need a standard methods need to be referred because our data, okay, come out from our analysis of the sample are going to use for all other purposes, official purposes such as to the court, all right, to prove something at the court, for the reporting. If you, as a chemical engineer, want to report like the case example that we discussed, which is the coal quality, all right, all need to be reported officially and also properly. So we need to refer to the standard method that being accepted globally. Okay, what does a standard method mean? Okay, the standard method meaning that a method that have been developed and been proved that the method is right. For example, we are talking about analyzing the moisture in coal. So there will be, okay, previous researcher or analyst or scientist, or we call as analytical chemists, have done the process. Okay, they have tried all several methods and they have found the best methods, and the best method also being practiced by others and also proof that is the best method that provide a good result. So it will be documented, okay, by anybody such as ASTM, American Standard, and what we call SSTM. There's an acronym. There will be the a full name of ASTM. Okay, and also AOAC. Okay, also US EPA, US Environmental Pollution Agency. Okay, and then Codex and so. Okay, we have a lot of body that come out with a standard methods. Okay, what you do is you need to refer the standard methods and do the analysis, and then you quote the same method. This method has been done. This analysis has been done based on standard method ASTM, and there will be code there, ASTM, for example, 0134 for moisture analysis of coal sample. That is example. Okay. So when we refer standard method, so people will know, okay, this study or this analysis have been done with standard methods. Okay. What content is the standard method? Okay. The method of sampling, the method of sample preservation, sample preparation, and until analysis is complete in the standard methods. Okay. Meaning that you cannot just do whatever you want to analyze a sample. You need to refer to the standard methods so that your report will be accepted, officially, and also at international level globally. And also you can write a scientific paper about the analysis. Understood, guys? Okay. I believe, or have you know how to search for a scientific journal using online database system? Because you are UTM student, so UTM has subscribed a lot of journals. Okay, all you need to do is go to the library website, and then you click online database or online database and log in your username and password UTM ACID. Okay, and then you can browse any journal that you want. You can search any topics that you want. Okay, then it will be written there either you can download the journal or not. Okay, have you know about that, guys? Have you learned about that? How to download journals as a UTM student and staff? Okay, we can download journals that need to be subscribed. If you are not UTM or any university student, we cannot download the journal because we need to pay for the journal. But UTM or other university have subscribed for their student and staff. So all we need to do is just download from the portal. You know the method, guys, how to download journals? Come on, respond. Hello? Am I alone here? You already know, right? Okay, good. You are third year. So I expect that you already know how to download the journal. Okay. So method selection. The factors that to consider include on what chemistry principle the analyte can be analyzed or detected. Does it interact with electromagnetic radiation? Can it be precipitated with metal reagent? Is it an ion or hydrocarbon? Okay. And equipment. What equipment that going to use for this analysis for the sample? Okay. Are the methods valid or certified? Accuracy, detection limit, time, cost, and also number of analysis need to be taken, complexity of the sample, technical expertise, speed, and so on. Okay, a lot of things need to be considered before you want to do the analysis. Okay, this is a classical method, as I said, that the wet chemistry that we're going to learn in this topic, in this course, is both two methods, gravimetric and volumetric. Okay, before we have a really modern instrument, this is how the scientists do or the analysts do to analyze certain sample, certain analyte in the sample. Okay, gravimetric, mixing chemicals, and then some of the chemicals precipitate, filter the sample, and then get the precipitate and dry the precipitate, and then measure the weight of the precipitate and compare with the sample weight, and you get how much percent or concentration of the analyte. That is really messy method, right? Involve a lot of chemicals, a lot of process, and then you might be some error. Some of the precipitate have been lost. You leave it on the filter and so on. So that is a traditional or classic method that have been done previously before we have the modern instrument. Okay, as well as volumetric method, titration. Okay, you just stir the conical flask, you titrate. Okay, and then when the color change, you stop and you measure the volume. We have done that, or you will done that in the lab after this. And then also there might be some error. Okay, because you put extra of the solution inside the conical flask. Okay, and then there will be error, so the volume will be wrong, and so on. So that is the classic method. Okay, messy, okay, time consuming, and also involve a lot of errors, but you need to learn because it's the basic thing that involved in analysis. Okay, in this course also we're going to learn, but not so deep, just certain certain part of these two methods. So separation methods and spectroscopic methods. Separation or chromatography method and also spectroscopic method are two modern analysis, modern type of analysis involving instrument that we're going to learn in this topic. And also one more thing is electroanalytical method, but we are not going to learn about electroanalytical methods in this course, but you need to know that there's methods in analysis known as electroanalytical method. So that is sampling, a process to get a representative and homogeneous sample. Okay. And also deciding how to obtain a sample for analysis. Okay. And step involved in the sampling of bulk material. Okay. Let we go one by one. Process to get a representative and homogeneous sample. So representative means that the content of an analytical sample reflects the content of a bulk sample. As I said, the sample need to represent the bulk. Okay. And we want to preserve the sample to keep it really original, similar with the bulk. And it also be homogeneous, mean that the analytical sample has the same content throughout. Okay, we don't want to take the sample that is different from the bulk. Okay, we take the sample that homogeneous. Okay, almost 99.99% similar to the bulk. Okay, throughout. Okay, and then deciding how to obtain a sample for analysis depend on the first one is the size of the sample that to be taken. Okay, some of analysis that involve only a small amount of sample, so we don't need to bring a large amount of sample. Okay, the physical state of sample, we need to take a solid sample, so or liquid sample or gas sample, we need to know the physical state, so that we need to bring a specific instrument of sampling that we need. For example, we want to take the river water. So if you want to take a river water sample, so we need to do a sampling with what we call as the a Van Dorn water sampler. We need to have water sampler, or we need a solid sample from a sediment of that particular river. So we need a special equipment called as Ackermann dredge. So we need to grab the sediment at the bottom of the river to bring it up and take the sample. Or we need a gas sample. So how to capture the gas with the Tatla bag sample or with the canister? There are a lot of things involved in gas sampling. And then we need to do the chemistry. We need to know the chemistry of the material that to be assayed. Okay. Of course, we need to study first about this sample. Okay. What is the chemistry of the analyte inside the sample? Okay. Nothing can be done that would destroy or alter the identity or quantity of the analyte. Okay. Because we want to keep it as it is to bring to the lab. And then step involved in sampling of bulk material. Okay. We need to identify the population from which the sample is to be obtained, to collect a gross sample that is truly representative of the population of the sample, and also reduce the gross sample to a laboratory sample that is suitable for analysis. This one meaning that the size of the sample. Of course, you want to take the water sample to the lab. Do you bring 100 liter of the sample to the lab? Okay, you carry using your crane and so on to the lab. No, we take the sample appropriately with the size that we need, that suitable to be analyzed at the lab. Okay, we have the sampling of solid. Okay, for example, okay, the stockpile of grains. Okay, you see a lot of grains there. Then we need to take the sample, okay, to analyze the quality. Okay, take increment from surface and interior using grab method or motion method. Okay, remember, if you want to sample a really large population, okay, we need to take from several points, okay, so that it will represent the whole population. Okay, if you want to sample a compact solid like metals or alloys, so it need to be obtained by random drilling or sawing across the metal at random interval and collect them sawdust sample. Okay, we drill, okay, at the middle of the solids, at the bottom of the solid, okay, at several solid for example, metal alloys, rod, okay, and then we mix together, okay, and then we take a portion of it. Okay, inhomogeneity of the material makes sampling of solid more difficult. So the easiest way to sample a material is grab sample. The sample take at random and assume to be representative. The second, and then the third one is for reliable result, take 1/50 or 1/100 of the total bulk. The larger the particle size, the larger the gross sample should be. Okay. All right. Then for solid sample, if we take, for example, a powdered sample, a dust sample, okay, we have for about, after we take a several part of the solid sample, we mix together, and of course we have a lot of it. We need to reduce the size. Okay, what we can do, we call as the cone and quartering method. Okay, we collect, we gather all the sample that in powdered form, okay, or a sandy form, okay, like a sand, okay, that we obtain a random sample from a bulk material, okay, for example, from conveyor belt, okay, or grain sample or coal sample, that periodically transfer portion into a sample container. Then we take the gross sample, and also that's suitable with the laboratory size. Of course, we bring, for example, a bag of the solid sample in the powdered form. And then the third step, when we arrive at the lab, we do cone and quartering method. Okay, the sample is crushed. For example, if your sample is originally not in powdered sample, it's a stone sample. Okay, we bring a bag of stone sample, and then we crush it. Okay, until it become powdered. Okay, and then we mix together, and we do a cone shape, a conical pie shape, and then we flatten the shape. Okay, we flatten it, and then we cut into equal quarters, and then we have two opposite quarters. We remove two opposite quarters, and we take only two. Okay, the one that we take, okay, both of the quarters that we take, we make a conical shape again, flatten again, and do the process again and again until you get a small portion of sample, or the suitable portion of the solid sample. Okay, cone and quartering method. Okay, guys, do you have a TikTok? Okay, do you have TikTok account?
Yes, Doctor.
Okay, I will send in the group the video of me showing how to do this cone and quartering method. Okay, and in my TikTok, so you will learn from that. Okay. Sampling of liquid, like I said, okay. Liquid sample are homogeneous and much easier to be sampled. Okay, the gross sample can be relatively small. If liquid sample are not homogeneous and have only small quantity, they can be shaken and sampled immediately. Okay, sampling techniques will be depend on the type of liquid. You can see in the photo. Okay, let me annotate a little bit. Okay, this is at the river. So what we use here, okay, is what we call as a Van Dorn water sampler. Okay, we can open the water sampler, and then when it arrives at certain depth with our with the rope that tighten join or tighten into the water sampler, at several depths we will drop the really heavy material on top of the water sampler, and then when it reach the water sampler at certain depth, it will grab the water, and we just take it back to the surface. For this technique of water sampling, okay, you can just do a YouTube search to know how the method's been done. Okay, using water sampler or Van Dorn water sampler. If the sampling site is just shallow like this, where's my mouse? Okay, okay. Okay, if the sampling site is shallow like this, just take the sample, okay, from the shallow river or a beach. Okay, and then you take the sample, and you can just take the sample at certain location, mix it together. Okay, at several points. You take the sample, mix together, and then preserve, and then bring it to the lab. Okay. And then for biological fluids, okay, you need to take the sample at different timing. Okay, remember the doctor said to you to take the sample, you need to fast. Okay, so you need to fast. And then some of the sample being taken at several times. If you do a COVID test, right, using saliva, you need to, you need to clean your mouth first. Okay, and then put your saliva into the container with a certain amount. Okay, if you do a nasal test, you need to, you need to make a circle in your nose at the end of your nose, right? It's really hurt, right? So, and then you need to take from another part of your nose, okay, to take the liquid at the top of your nose, okay. So that is the sampling of biological fluids, okay. For blood, some of the doctor they take the blood from different part of the body, okay, to analyze, okay. That is the thing that the timing also important in body fluids, biological fluid, okay. For example, the composition of blood varies before and after meal. Of course, the doctor asks you to fast before taking the blood sample. Sample is collected after the patient has fasted or for a number of hours. Okay. What happened to my slides? Okay, this is an example of a water sampler, Vendome water sampler. I have it. When we do a physical class after this, I will bring this water sampler to the class to show to you, okay, how it be done to do water sampling using water sampler. Okay, we need to put water sampler. We need to take out the stopper first, and then hold it here. At when we put the water sampler inside the sea water or river water at certain depth, we measure from the rope, and then we put the some of the heavy things that go through the rope, and when it push the button on the water sampler will close. The cylinder will be closed, and it trap the water at certain level, and we bring it to the top. Okay, I hope you know the mechanism, but it will be clearly shown to you after during the physical class that we're gonna do after this. Okay, this is the video. Okay. Okay, this is how water sample being taken. So sampling of gas, okay, it tend to be homogeneous. Okay, the large volume of sample is required because of the low density. Okay, the example is environmental air using high vol sampler or Tetla bag. Okay, this is the water sampler, high vol water sampler. Okay, this is a Tetla bag. Okay, we use a pump to pump the air sample inside the bag. Okay, the bag previously is flattened or being vacuum, and after that we pump the air inside the sample. Inside the Tetla bag, and then we close the valve and we bring it to the lab immediately. Okay, and also we have a really good one. The modern one is not included in the slides. Okay, but after this I will show you in the class. Okay, the modern one, the modern method using passive sampler, adsorbent, and also the what we call as the a canister, gas canister water sampler. Sorry, it's a gas sampler, canister gas sampler. And then we have sample storage and preservation. Like I said, after we take the sample, it need to be stored properly and to preserve properly according to the standard method. Okay, the sample container, the objective is to preserve the nature of the light contained in the sample as similar as possible during the sampling process. And the sample container materials can introduce either positive or negative errors in measurement, particularly ultra trace level, by contributing contaminants through leaching or surface desorption. Okay, so as the conclusion for the sample storage and preservation is when we take the sample, it need to be stored properly. Okay, the sample storage or the samples container need to be with a specific material. Okay, for example, there's some analytes that if for example we want to take water sample to analyze the oil and grease content. So the sample container should be or we want to analyze the organic content inside the water. So the sample storage or sample container should be in glass container or glass bottle. Because if you use a plastic bottle, it will disturb the nature of the analyte. Okay, for example, again, some of the sample container it need to be, it need to use amber glass bottle, because when using amber glass bottle, the light sensitive analytes will not being destroyed throughout the process, because it will be exposed to the sunlight. Okay, if you use normal bottle, the sunlight will decompose the analyte. So we need to use amber bottle. Okay, you know amber bottle? Yeah. Okay. After this, I show you. So there's also some sample need to be refrigerated or freeze directly after sampling process. And also some of the sample need to be acidified with 10% of the nitric acid. Okay. This sample, okay, that need to be acidified is normally for analyzing of analyzing of metals analytes. Okay. The water sample that we need to bring to the lab for metal analysis, okay, normally we acidify with 10% of nitric acid to make sure all the metals are in ionic form. Okay, it's not reacted or precipitated by other things in the sample. We need to put acid to make sure that all the metals inside the sample are being in ionic form. Okay. Okay. This is metal. This is the metal containers special for hydrocarbon sample. If it, for example, that I showed in previous class, the oil spill at Mexico Gulf, right? So we need to take the hydrocarbon sample. So the special method for the hydrocarbon samples, okay, we need to use the metal container like this. Okay, and then amber glass bottle, amber vial bottle for light sensitive sample. Okay, and polyethylene normal plastic bottle for inorganic trace analysis. Again, okay, the Gulf of Mexico oil spill. Right, so we have come to the end of the part of the first thing until the sampling, sample preservation, sample storage, and also yes, until sample storage. Okay, and after this we're gonna learn about the concentration and general procedures on solution preparation. Okay, and before we go further to this topic, okay, there's one group assignment that we need to do. Okay, so what is a group assignment? But you don't have any group yet, right? Okay, you have about 61 students. So Rushaidi, Shaidi, can hear me?
Yes, doctor.
Okay, so what you need to do with the balance time, guys, all of you, okay, is you just perform a right grouping, okay, with only 5% in a group, okay, except for one group will have 6% because we have 61, right? So there's some requirements that I set for the grouping. Okay, the first one is the group member must have all genders, okay, women and gentlemen, okay, ladies and gentlemen, okay, boys and girls, okay, and also all group must have different races. Okay, we don't need the group only have Malays, and this group only have Chinese, this group only have Indians, this group only have Arabs. Okay, mixed together. Okay, and also what else? I just forgot the requirement for the grouping. Okay, I think that's all. Different gender, different race. Okay, different gender, different race. You are from similar course. Similar program. SETK. That's okay. All right, what else? Different gender, different race, 5% per group. Okay, I think that's all the requirement for the grouping. Okay, so with the balance time, okay, for the class, just okay. After this, you form the group, but I need to show you what is the assignment about. Okay. Okay, guys, you can see my slide now. Hello. Okay, good. Okay.
Yes, doctor.
This is a group assignment. Remember how many percent the marks of the group assignment? You remember? How many percent? Referring to the CI, course information. 10? Am I correct? 10%, right? Hello, guys. Hello. How many percent? Check it back.
10% of
10%. Okay, good. All right. So you need to have a group that based on requirement that I said to you previously. Okay. So it is a case study. Okay. What is a case? A chemical waste was dumped into a river, causing a water, soil, and air pollution. So, and officers from environmental department, one, fire department, or especially for hazardous material or hazmat, two, Department of Chemistry, three, Department of Fisheries, four, and local residents, representative of local residents, five. Okay, 5%. Okay, have to discuss to investigate the case. Okay, so assume you are in the group of those people. Plan the sampling and sample preservation process to investigate the case. Plan what? Plan the sampling and sample preservation. That's all. Sampling and sample preservation. How to take the sample and how to preserve. To investigate the case. And what you need to identify. The first one is the what sample should you take. Okay, number one. Second one, which standard method that you prefer. Okay. And then number three, how to preserve the sample. Number four, how to store the sample. And number five, how you should analyze the sample. Okay. Okay. This is how you need to do in this, assignment called as different thinking hat jigsaw group. Okay. The first one is from the initial group, from your the grouping, the group that I asked you for you to have 5 members. Okay, you identify who will be the environmental officer, who will be the fire department specialized for hazmat, hazardous material, who will be the Department of Chemistry officer or chemist, who will be the Department of Fisheries officer. Why Department of Fisheries? Because it is a river pollution. Okay, so the Department of Fisheries needs to be involved because it affects the fishermen. Okay, and then the local residents representative. So 5% in the group you need to identify, and after that you have to be ready to the next group. What is the next group? All the person with the specific task, okay, or specific what we call as carrier or function. Okay, for example, a fire department's hazmat will be gathered together. Fisheries department officers from all group will be gathered together to discuss, and also all the representative of local resident will be gathered to discuss all 5 questions that we given previously. Okay, and then after you ask what you need to discuss in this similar position group. Okay, from all group from all 5 department officer from all group, all fisheries department, local resident, chemist. Remember what else we have? Also chemist and also environmental officer. 5 position need to be gathered from all group. You discuss from with your own perspective of position. 5 department, fisheries department, local residents, environmental officer, and also the department of chemistry. What you need to take, okay, or what you need to do with all these question from your perspective of position. And then after that, okay, you come out to the original group. Okay, come out to the original group and prepare the sampling and sample preservation planning, answering all the questions. Okay, that you need to do, considering every role's point of view. Okay, because when you discuss with the similar roles, you have discussed as a chemist, we need to take this sample. Okay, this preservation need to be taken. Okay, and as a fisheries department, this sample need to be taken. So discuss back in the original group after you discuss with your different role. Fight back in the group what sample should be taken. Okay, what standard method should be referred, how to preserve the sample, how to store the sample, and how to you should analyze the samples. Okay, the sample can be more than one. Okay, depend on your discussion. Okay, in your initial group, and also you after you come back from the similar group, you bring back to the original group, you fight. This sample should need to be taken. Okay, and all answering all the question. All right. And then submit the task in form of creatively mind map, table form, video also can, and so on. All right, in the e-learning platform. So don't worry, we will do all this discussion in the class after this. Okay, what you need to do now is grouping. Okay, set a group. Okay, and also set the position of every group member. Okay, and also what else? Set a group. Okay, group name. Okay, after this, in the WhatsApp group, you will list down all group with numbers. Group 1, what is the name of the group, and then who are the members. Okay, you will list in the WhatsApp group after this. I need to have a group tonight. Okay, and then this is the marking rubric of the assignment. Okay, so the criteria is understanding of the scenario of the case study. Okay, the weight is 20%. So 4 marks if you have directly relevant. Okay, 3 is accomplished but somewhat relevant, and 2 developing, no but remotely related, and number 1 beginning, totally unrelated. Okay, and then organization of the written planning. Okay, of the at last we come up with a planning. Okay, we come up with a planning. I said that in terms of maybe mind map, or table, or clear methods with numbering. Okay, with photos and so on, creatively. Okay, good organization of the planning. Okay, you have 4 marks, and then 3 marks for point are somewhat jumpy and so on. Okay, 2 for organization jump and around, beginning and ending unclear, and 1 mark for poorly organized. And then quality of sampling methodology. Okay, supporting details specific to subject, you have 4 marks there. Accomplished but some details are non-supporting to the subject, we have 3 marks. And then details are somewhat sketchy, do not support topic, 2 marks, and 1 mark for unable to find specific details. And then that is for 25%. And then 25% also for general chemistry terminologies and theories. Okay, you put a right name of chemical with the formula, also right, no errors, you get full mark. If you have some errors, 3 marks, more errors, 2 marks, and a lot of errors, 1 mark. Okay, interest level. Okay, the vocabulary is varied and supporting details, you get full mark. If supporting details useful, the full mark is vivid, right? And then 3 marks is useful, and 2 marks is for lack of color. Okay, and also 1 mark needs descriptive words. Okay, and then timeliness, report on time, submit on time, you get a full mark, and if not submitting on time, the marks will be decreased, right? This is the rubric for the marks. Okay, the process of discussion will be done in the class. Okay, but you need to do now tonight is the grouping and as well as the position of every person in the group, so that when we have a physical class after this, we have a clear role for everyone, because you know the time is so precious. We need to do the activity really you know, in appropriate time. We don't waste any time to just arguing, you don't want to be this position and so on. So settle that one tonight. Grouping, okay, group number, group name, okay, and also the members with the role in the WhatsApp group by tonight. Okay, understood, guys? You have any question to ask about this assignment?
Doctor, I have one question regarding the group member.
What?
I have one question regarding the group
Yes, okay.
member.
Please.
Just now, doctor mentioned we need to mix the races. It means we need to have all races in one group, or just
Yes,
as long as it mix?
No, I don't need a group with all similar races. You need to mix. At least you have 2 races, or of course, it's 3 better. 4 is much better. But don't need. I don't want one group with one race. Okay.
Okay.
And
thank
also,
you,
I don't want
doctor.
group with same genders. Also, I don't want. Even for example, you have a lot of girls in the class, okay, and also several men, but at least one boy in the group is also okay.
Okay, thank you, doctor.
All right. I will give this you know, this information regarding this assignment in the e-learning, okay, the PDF. Understood, guys? You have any question? Because I will stop the WebEx if you don't have any question, and then you keep on doing you know, keep on grouping process until you come up with all group. Everyone have group and also role by tonight. Okay.
Doctor,
Yes.
do I have to form the group?
Who's that?
Rushaydi.
Okay. That's a really good question. If the class rep and also deputy class rep can manage it, if you have you know, agreement with all group, all class members, Rushaidi, please make it for us, okay? And together with who's our deputy, Jayan, or what? I forgot her name. Who's our deputy? I need to refer. Called Jayan, right?
Yes, doctor.
Okay, so if all group member just agree that only Rushaidi and also Kok Jayan arrange, is better, much better. Okay, but if they have arranged, okay, please you need to discuss among all of you after Rushaidi and Kok Jayan come up with a proposal of grouping, and then please present to all first, okay, if you are agree, okay. Okay, meaning that I any agreement from all of you. I don't want after this, oh doctor, I want to change group. No, it must be done by tonight. Okay. You discuss among all of you. You can use you know, Webex also can. Also you can use what a WhatsApp group and also can. If I left the group, one of you will be the host for the Webex session, so that you can keep on discussing without me here. Okay. Anyone else who didn't scan for the attendance yet? All of you already scanned? Okay, full house. Really good. Okay. So are you guys ready to discuss about the grouping? Guys, you have question in the chat? Okay, no. Okay, so if you're ready, I left the WebEx now. I just leave it to Rushaidi and Jayan to handle. Okay? Okay, guys?
Okay, Doctor.
So thank you so much for tonight. And then keep on discussing and also forming group. All the best. Okay. Everyone should tolerate. Everyone should play their part. Okay. In this section. Okay. To make it easier and faster. All right. Thank you so much. Till we meet again. Assalamualaikum and good night. Bye bye.
Thank you, Doctor.
All right. Welcome.
Thank
For
you,
those
Doctor.
yes, for those Muslims, please
Thank you, Doctor.
please recite the prayer. Okay. Tasbih kifarah surah.
Thank you, Doctor.
Okay. I think you are not you cannot left the WebEx first. I only me just left the WebEx so that you can settle the discussion first. It depends on you how many minutes you want. Okay. Thank you so much.